Welcome back to My Tech Home. Today we are breaking down one of the most important concepts in generative AI basics for beginners, that is fine tuning. If you have used an AI like ChatGPT or Gemini, you know they are incredibly smart. But sometimes when you ask them to do something very specific for your job or your business, they kind of miss the mark or start hallucinating, right? Sometimes they sound too robotic, or sometimes they don't understand what you're asking, right? To fix that, we don't need to build a new AI from scratch. We just need to fine tune it. So today in this video, we will see how to fine tune a model. I'm going to draw out exactly what fine tuning means and why it is a game changer for using AI. And what are the biggest mistakes you need to avoid if you try it yourself. So let's look at it, how it is built. The first step is called pre-training. So let's imagine um, we are sending a person into the world's biggest library and forcing them to read each and every book present in that library. So there can be history book, math, science books, sci-fi, cooking, different kinds of books. Okay. So when that person come out, he should know a little about everything, right? Or he can understand how human languages work. So this is what a standard general LLM is. But now imagine we want that person to become a specialist in a field, right? Like in a sports field. So knowing about cooking, math, science won't help him in the sports ground. Okay. He has to go to some sports school. He has to take some specialized coaching. Only then that person will be able to play that game. So this is called fine tuning. It is taking an AI that has already read lots of information from internet, but we give it a small and highly specific data so that it become a master of one specific topic. We don't teach it how to speak in English or how to play a game. We are just teaching it how to be a good sports person, okay, a lawyer or a doctor in that specific field. So you might be wondering, why is this required? Can I just give the AI a long set of instructions in my prompt? You can do that, but that is likely making the AI carry a very heavy backpack full of rule books every single time it takes a step. Because when you give it a long prompt instruction in the prompt, you are giving it a huge set of rules. Okay, you are giving it 5 to 10 pages of examples every time you ask a question. Okay, just telling it how it should act and how it should answer your question. So that becomes very slow and it costs a lot of computer power. So sometimes AI just ignores the heavy backpack anyway. A fine-tuned model doesn't need any heavy backpack or heavy rule book. It has permanently memorized your rule book. The knowledge is right into its brain. It is more accurate because it actually sounds like your brand or follows your exact formatting. It is cheaper and faster also. So fine tuning is powerful, but it is very easy to mess up. So if you are going to feed the AI specific data, you have to watch out for three major traps. Number one is bad data. If you give it confusing, messy, or incorrect examples or data, so it will learn to be confusing and messy. So in fine tuning, having 500 perfect examples is infinitely better than giving it 10,000 sloppy ones. So quality beats quantity here every time. Number two is catastrophic forgetting. Yes, that's really a scientific term. So if you train your AI or LLM model too hard on a specific job, So it might actually forget the basic stuff on which it was previously trained. Okay. So it might become great at writing computer codes, but it can forget basics of computers. Number 3 is overfitting. So this is when AI just memorize your examples like parrot without actually understanding the underlying concept. If you ask it a question that is slightly different from your training data, it completely frees up or fail. It learned the answers to practice a test, but it didn't learn the subject. So, to wrap up the theory, pre-training builds the brain, but fine-tuning gives it a purpose. It takes an AI from a jack of all trades to a specialized expert tailored exactly to your needs. But drawing it on whiteboard doesn't serve the purpose. So on this channel, we'll not just talk about it, we will actually build it. So don't go anywhere because we are jumping straight into the code. I'm going to show you exactly what this looks like in the practice. So if we are going to use Google Colab for this purpose, it will pull, first of all, we'll pull a open source model straight from the Hugging Face. And I'm going to walk you through the Python code line by line to fine tune it on a custom dataset. Even if you are a total beginner to coding, stick with me. I'm going to explain each and every step. So let's get started. So here, this is a Google Colab notebook. In my previous video, I showed you how we can use open source LLM model that is called GPT-2 from Hugging Face. So in that model, we first of all we used that model. We tokenized. We install, load the pre-trained model tokenizer and model for GPT-2, and then we gave it a prompt. Using tokenizer, we encoded that prompt into input IDs, and after that we used the model, same model, LLM model that we have installed from Hugging Face, and ask it to generate output IDs based on the token ID that we have given it to it, and then we use tokenizer to decode that particular output it has generated, and then it generated the response. But this response, our question was write about a fruit apple, and its response was, so what do you think? Do you have any tips for aspiring fruit-loving people? Let us know in the comments below. So this was the output this LLM model has generated without any training, okay? Because it is a pre-trained model. So now we thought that we will train it and we will fine-tune this model based on a custom dataset that is Salesforce Wikitest dataset. And this dataset is available on Hugging Face. So we thought that we'll train this model GPT-2 and we'll fine-tune it, and then after once we train it, we'll give it a prompt and see what kind of output it generates. Okay, so here is the Salesforce Wikitext dataset on Hugging Face. Okay, so in this data, these are the records that this data contains. So if you want to see one kind of record, you can just click on it. So this is the complete data. One of the sample of a record. The game's battle system, the blitz system is carried over directly from Player Chronicles. During mission, players select each unit using a top at the red down perspective of battlefield map. So this is some of the record. Okay, so we are going to train our model using this data sets. Okay, so now let's go back to Colab. So first of all, our first step after uh, finding out which which pre-trained LLM model we are going to use, the first step is to load its tokenizer and model, right? So for that, we will use auto tokenizer and auto model for casual LLM from the transformer library to achieve this purpose. And auto tokenizer dot from pre-trained GPT-2. So from here, we will use this tokenizer that will convert text into numerical IDs, right? And auto model for casual LLM is the actual language model that is capable of generating text for some prompts. So once GPT-2 tokenizers and models are loaded successfully, you can see everything is green. Our next step is to load dataset. But before loading dataset, we have to initialize, we have to first import load dataset function from datasets library. Okay, because this is the function that will read Salesforce Wikitext dataset and it will further tokenize it and then prepare it for language modeling by grouping text into blocks and creating input IDs, attention marks. So that's a long process. We'll cover that in coming code walkthrough. So a first step is to import a load dataset function from dataset library. So we have done it here. So load dataset function imported successfully. Now next step is to load our dataset, that is Salesforce Wikitext, and in that we are going to use this schema Wikitext 103 row v1. Okay, so our next task is to give this particular data set to load dataset function so that it can read it properly. So here this dataset is loaded successfully. You can see that this dataset dictionary is also here. That tells that it has test records. Number of test records are 4358. This is the number of train records and this is the number of validation records in the dataset. Okay, so now the dataset is loaded successfully. Our next task is to tokenize this text data, and this function will take batches of examples and it will tokenize the text using preloaded tokenizer function, convert them, and it will return token IDs, or you can say input IDs or numerical IDs, and attention masks. Also, it will ensure that your special mask token is marked as true. Okay, so this is the tokenization function where we are passing this data set and it is using its tokenizer function further and just reading it and returning tokenized. But the thing is, this process will take very long time because our data set is huge, right? So to make it fast, the good thing is to write down a function that will break this text or token IDs text into blocks. Okay, and that will make it really fast. So let's see how to do that. Yeah. With this tokenization step that we have just seen, that will result in a sequence longer than the model's maximum length, and it will indicate, give some warnings also. So to work on it, we will define a function group text that is used to group tokenized text into three fixed size blocks of 128 tokens. Okay, and after that, based on this size, we will do data collating. So here we have defined block size, and this function group text will work on our data set. Okay, and finally it will return input IDs, attention marks as the result. Okay, and here is our this tokenized data set that from here we are using this group text function. We have marked batch as true, and a size of each batch is 1000 records. Okay, and it will take 4 rounds of execution. Now once dataset group, so once this is done, next step is to define training arguments. Okay, so what are training argument is a very important process of fine-tuning, because this includes setting of output directories, temperature, learning rate, evaluation strategies, and batch size of a data set. Okay, and it will help us in defining a trainer for this particular fine-tuning process. So here we will import training arguments from transformer, and here we are setting its input arguments like output dir, per device train batch size, per device eval batch size, learning rate, local dir, variant accumulation steps. So once this is here we have defined this training argument successfully. After this, we will do data collator. So what is data collator? Data collator is responsible for taking a batch of examples and preparing them for the model. Typically, we're padding them to the same length. So if a length of a text, say 4 words long, and another text is 6 words long, so it will pad previous text by 2 spaces to make it of same length. So both texts will become of same length. So for casual language modeling, data collator for language modeling is accurate. So this is data collator for language modeling. We will import it from transformer library, and that's how we will define it. Data collator for language modeling. In this, we will give it a tokenizer, and MLM is marked as false. So here it is initialized successfully. Once that is done, next task is to define a trainer or initialize a trainer using training arguments and data collator. So that's how we'll do it. We'll import trainer using from the transformer library. And once that is done, we'll set its argument as initialize it with the help of model, training arguments, data collator, LM dataset, train dataset, and validation dataset. After initializing trainer, next task is to train the data. Okay, so how will we do that? We will just call trainer.train, and it will train the data. If everything goes well, it will show us that it is done. After this, next step is to save our fine-tuned model and tokenizer, because we want to use it later, right? Once everything is done, it is trained successfully. We should be able to load and test the model later also, right? Without retraining it or recreating it. So for that, we will use trainer.save model and tokenizer.save pretrained, and it will save it in output directory that we have set up in training arguments. So with the help of these 2 lines of code, we'll do it out. Trainer.save model and tokenizer.save pretrained be in output directory. So you can see it is done. So fine-tune model and tokenizer are saved into GPT-2 fine-tune Wikitext output directory, right? Once everything is done, our last task is to evaluate the trainer, right? We have to evaluate it and check it what kind of how much data is lost, how many training reports it trained, how much time it took to train. So for this, we'll call this method and print the return evaluation matrix here. Trainer.evaluate is the function we'll call. Okay. If eval loss is eval results, perplexity, it will print everything. So this previous code, this code block evaluated the fine-tuning model and printed the evaluation results, including loss and perplexity. This completes this subtask. Everything is done. Now next logical test is to test fine-tune model text generation capability, because we have used GPT-2. Our base model was GPT-2 that was pre-trained, and it was a text generation model, and we use Salesforce Wikitext dataset to fine-tune it. So now we want to see if we give it a prompt, what kind of output it will generate. So for testing fine-tune model, the steps are similar to the basic LLM model that we have followed in our previous video to generate a text. So first of all, like a basic LLM model, we will define prompt. We will use tokenizer dot encode for the uh, a breaking for creating tokens out of this prompt. Okay, and it will turn into input IDs, and we will use this input IDs on model.generate input IDs. Maximum new token will be 50. Temperature will be 0.7. Pad token is end of 9. End of statement token ID, right? So here model will generate an output using fine-tuned model, and then we'll use tokenizer.decode to convert these token IDs back into the text, human readable text. So tokenizer.decode output 0, and here it has generated token IDs back into human readable text, and here we are printing it. Okay, so the prompt was quick brown fox jumps over the, okay, and generated text is the quick brown fox jumps over the edge of the net and snatches the stick. You are going to get hit by a dog, says the fox. You are going to be in hurry, says the fox. Don't worry about. So we allowed only 50 tokens. So our output is that's why it is trimmed here. So if you increase, number of tokens, output tokens, it can write more, I'd say. So that's how we can fine tune a pre-trained model using a custom dataset. You can define your own dataset. You can take dataset from Hugging Face, because Hugging Face has lots of datasets in it. If you want to come here, you go to Hugging Face in datasets. So lots of datasets are there. From here you can define your task, what kind of task you want to do. Like our task was to generate a text. So we will choose category as text generation. Okay. So these are the data sets that will help you in training a model for text generation. All right. If you have a category, so say text classification, means you want to do sentiment analysis, you want to classify your text. So these are the data sets that can be used for classification. Okay. So from here you can choose it has immense number of a large number of texts and models available on you, where you can with which you can play around and do lots of trials and hands-on on the models and data sets. So that's how we can fine-tune a model using a custom data set and use it. So since we have saved it in our output directory, we can reuse it whenever we want. So this model has been fine-tuned for us now. So similarly, you can use other models also, like I can show you for text generation. These are the models for text generation. So you can use Locotrainer, NVIDIA, Nemotron. You can use Minimax. These are all text generation models. But some models are very heavy. Servam 105B is also present here. Okay. So you have to see how many billion parameters these models have, because it will take time to load it on your system these are very heavy, if that model is very heavy. So you can set number of parameters from here. So based on that, these models will get filter. Like all NVIDIA is in not here, it's filtered out, right? Servam AI is also filtered out. So heavy models are not here now. So you can use these models for quick results. In my next video, I will show you how you can create RAG on these predefined models, pre-trained models, and how we can do RAG and fine-tuning both on a model. Until then, thank you. Thank you for watching this video.